Good day, everyone. So, today we shall be looking at another topic wave particle duality. Actually, it's talking about the two nature of light. So, in other words, we are looking at the nature of wave, light wave. All right, without much ado, let's dive into this topic. Okay, light actually has two nature. Of course, we know that the light is an electromagnetic wave that radiate out from a source with a velocity of 3 times 10 to the power 8 meter per second, and it's exhibit concept of reflection, refraction, interference, even diffraction. So light behave like a wave when it reflects, when it refracts, and when it interfere or diffract, as seen in this video. Look at this video now. You could see that light here is behaving as a wave. You could see it here now. It's behaving as a wave. But then it has been verified that light can also behave as a particle. And when it does that, it is called photons, as seen in this video here. You can see it here. Here it's behaving like a particle because as it's coming here, as it's incidenting on this object here, you could see that it's displacing the electrons there and the electron is moving out. So because it could displace an electron, that means it's a particle. All right, so that is why we could say it has dual nature. It behaves as light and it behaves as particle. And the good example where we could see there, where we can see light behaving like a particle, is in photoelectric effect. In photoelectric effect, we know that when light falls on an object, that object emits electrons, and that's because the light behaves as a particle. So these are the dual nature of light: behave as a wave and as a particle. Okay, so let's talk about the scientists that discovered this nature of light. Okay, when it comes to the particle nature of light, Sir Isaac Newton was the one that proposed the theory that light has particle nature. Okay, he calls that corpuscle, and the Christian consider light to be a wave. All right, De Broglie still supported the idea of Isaac Newton that light behave as a particle, and he postulated an equation that if light is a particle, then it has a wavelength, it has a mass of m, and it has a velocity of v, where h is a Planck constant. So by formula, the wavelength of that light equals Planck constant over mv. This equation is known as De Broglie equation. E and Sir Newton actually took light as a particle. All right. Having said that, let's talk about another principle known as the uncertainty principle. The uncertainty principle was propounded by Heisenberg, and it states that it is impossible to know the exact position and velocity of a particle simultaneously. If you watch this video now, you see a particle moving. Now, Heisenberg said it is impossible for us to know the position of this particle at the same time the velocity of the particle simultaneously. He said it's never possible. Aside that, it's not also possible to know the momentum of that particle and the position of that particle at the same time. He said it's not possible. And lastly, he said it's not possible to know the energy at which the particle is moving with and the time it takes the energy to move simultaneously. This principle was propounded by Heisenberg, and it was named after him, Heisenberg uncertainty principle. So he came up with the equation that delta x dot delta p is greater than or equal to Planck constant. The h there is the Planck constant, while the s represents the position of the object, p represents the momentum of the object. So in this case, momentum and position of the cannot be measured at the same time or simultaneously. Another equation that they came up with is delta x dot delta v is greater than or equal to Planck constant. Also here too, velocity, like we said earlier, and position cannot be measured at the same time from this equation. And lastly, delta E dot delta T is greater than or equal to Planck constant. Again here, it's saying that the energy and time cannot be measured at the same time. So this principle is just telling you that these values, these quantities, the values of the quantity can never be measured at the same time. So these are the concepts we need to know in wave particle duality of light. All right, so we shall be drawing the curtain here. Thank you for listening. Goodbye for now.